Newton's second law of motion states that the force is equal to mass times the acceleration. And so what we need to do is distinguish between mass versus weight. There is a difference between them. The mass is the amount of matter that an object is made up of, but the weight is the force that that an object exerts due to gravity. So the weight of an object can actually change depending on what the gravity is present. And therefore, this changes the force of gravity of the object. So the force of gravity is equal to the mass times the acceleration due to gravity. So weight is going to equal the mass times gravity, depending on where you are. If we're on the Earth, then of course gravity is equal to 9.8 meters per second squared. So therefore, weight is a force and is measured in the unit of newtons, which is abbreviated with a capital N. When mass is in kilograms and acceleration is in meters per second squared, then the unit of force is in newtons. Meaning, if you take kilograms and you multiply it times mass over seconds squared, which is acceleration, you end up getting kilograms times mass per second squared, and this is actually equal to a newton. And so a newton can be broken down into the units of kilograms times mass per second squared. 1 newton is equal to the force required to accelerate 1 kilogram of a mass at 1 meters per second squared. So let's do some practice problems. Realize that your equation is force equals mass times acceleration. And if we're on Earth, then we're dealing with, if an object is falling, then you may be dealing with force equals mass times the acceleration due to gravity. So in this case, how much force, so force is what we don't know, is needed to accelerate a 1,400 kilogram car, so the mass is equal to 1,400 kilograms and 2 meters per second, which is 2 meters per second squared. So our acceleration is 2 meters per second squared. So we're going to plug in, so we're solving for the force. So force is equal to the mass, which is 1,400 kilograms, times the acceleration, which is 2 meters per second squared. And so the force is going to equal 2,800 newtons. So Newton's second law proves that different masses accelerate to the Earth at the same rate but with different forces. We know that objects with different masses accelerate to the ground at the same time. However, because of the second law, we know that they don't hit the ground with the same force. So although these two objects will fall, they will accelerate at the same rate. When they impact the ground, they will impact it with a different amount of force. Obviously, the larger boulder is going to impact the ground with more force than the smaller one. All right, another few practice problems just to make sure we understand. So what acceleration, so I don't know acceleration, will result when a 12 Newton force, so they gave me the force, applied to a 3 kilogram object. And that would be our mass. Okay, they also ask, what about if it's applied to a 6 kilogram object? So we have a second problem. What is the acceleration when a 12 Newton force is applied to an object with a mass of 6 kilograms? So we'll be doing two different calculations in this particular problem. So because my equation, as it stands, is force equals mass times acceleration, but I'm trying to solve for the acceleration. So I'm going to rearrange the equation by dividing both sides by mass. This way mass will cancel, and so acceleration is equal to the force divided by the mass. And so I'll take 12 newtons divided by 3 kilograms. And 12 divided by 3 is going to give me 4. Newtons divided by kilograms is going to give me an acceleration of 4 meters per second squared. Okay, here again, we're going to do acceleration is going to equal the force, 12 newtons, divided by the mass of 6 kilograms. And in this case, we get 2 meters per second squared. So okay, a net force of 16 newtons, so my force equals 16 newtons, causes a mass to accelerate at a rate of, so it's going to accelerate at 5 meters per second squared. Determine the mass of the substance. So in this case, recall force is equal to mass times acceleration. However, mass is what I'm solving for. So I'm going to rearrange this by dividing both sides by acceleration, canceling that. And so I'll get mass is equal to the force divided by the acceleration. So 16 newtons divided by 5 meters per second squared. Recall that because we're getting mass, we're going to end up with kilograms. And so 16 divided by 5 with 1 sig fig will be 3 kilograms. Okay, another example. How much force, so the force is my question mark, is needed to accelerate 66 kilograms, so that's my mass, 1 meter per second squared, and so that's my acceleration. Our equation, F equals ma, can remain as it stands since force is what I'm looking for. So I'll do the mass times the acceleration, and that's going to give me a force equal to 66 newtons. One more. What is the force? So force, I don't know, of a 1,000 kilogram elevator, that's the mass, and it's falling freely at the acceleration due to gravity, 9.8 meters per second squared. And we can actually call this G for gravity. And so my equation is going to be F equals ma, but since acceleration is gravity, we'll actually call it F equals mg. And so I'm going to do the mass times gravity, and that's going to give me 9,800 newtons as my force.